Hello students, myself Tejaswini, lecturer in ENC, SJ Government Polytechnic, Bangalore. And today we are going to learn, or I am going to give a lecture on single bit instructions. In the previous sessions, we have learned the different types of addressing modes, that is we have learned 5 types of addressing modes, that is immediate, register, direct, indirect and index addressing modes. And after that we have learned the instruction sets, different types of instruction sets. First we have learned the data moving instruction set. How to move the data from register to register, or by using all the addressing modes, how we can transfer the data. Then next we have learned the arithmetic instructions, that is add, subtraction, multiplication, division and how to increment and decrement. Then we have seen the logical operation, and, or, not, XOR, okay. Then after that we have learned the rotate instructions, the rotate to rotate, how to rotate right and how to rotate left, and with carry and without carry. Then we have seen the exchange instructions also. After that we have seen the jump instructions, that is branching instructions. In the branching instructions, we are having two types of instructions, conditional instructions and unconditional instructions. For the conditional instructions, we will be having a condition based on that the program flow will change. But in the unconditional instructions, it will not be having any condition. It will just jump to the specified address. Okay. And next, after that, we have seen the ranges, the three different ranges we are having, that is relative range, absolute range and long range. Relative range and absolute range, these two are of 2-byte instructions, and long range, whichever the instructions we are using in the long range, they are of byte instructions. Okay. The relative range will be having from minus 128D to plus 127, and in case of absolute range, it is of 0000H to 07FFH. In case of long range, that is entire program memory 0 to 64K, or 0000H to FFFFH. Okay. And after this, we have seen the unconditional instructions. In the unconditional instructions, we have seen the three different types of instructions. One is LJump, SJump and AJump. Okay. Then after that, we have seen the conditional instructions. Generally, conditional instructions are of relative jumps, that is short jumps. They are of 2-byte instructions. So many instructions we have seen, that is JC, JNC, okay, CJNE, DJNZ, okay, so many different types of instructions, conditional instructions we have seen. So there, based on the condition, the program flow will change. Okay. And after this, we have seen the call and return instructions. Call. See, in case if you want to use the same program number of times, instead of wasting the memory space, we can go for the subroutines. Okay. So using the call instructions, we are having A call instruction and L call instructions. So we can call the subroutine. So every subroutine, it has to end with a return instruction, that is RET. And if you are calling the interrupts, then it has to end with the RETI, return from interrupt instructions. Okay. So till here in the previous sessions we have seen, and also we have done some of the programs. I think now you can easily write the programs, and can easily trace the instructions also. And today we are going to see, or I am going to give a lecture on single bit instructions. What are single bit instructions? See, in the previous instructions, we are able to change the 8-bit, entire 8-bit. Okay, see, clear accumulator. That means entire accumulator will be cleared to 0. For example, if we want to change the third bit in the accumulator, or if we want to clear the third bit in the accumulator, we can also change by using the single bit instructions. Okay, one by one we'll see now. See, the single bit instructions we are having is that is set bit. SETB bit, that is nothing but the set the bit. That bit will become 1. Clear bit. Clear bit means bit will become 0. Complement bit. Complement means if it is 0 it will become 1. 1 will become 0. JB bit, comma target. Jump to target if bit is equal to 1. JNB bit, comma target. Jump to target if bit is equal to 0. JBC bit, comma target. Jump to target if bit equals to 1, and then it will clear the bit. These are some of the single bit instructions. Now we'll see one by one. First one is set bit, that is SETB. The syntax is SETB and then you have to write the bit. Function set B bit. Set bit indicates that indicated bit to 1. So whichever the bit you want to make one, it will be set to 1. Set bit can operate on the carry flag or any other addressable bit. Here no other flags will be affected. Okay. Let us consider an example. The carry flag is cleared. Okay, initially carry flag is cleared. Output port 1 has been returned with the value 34H. So the port 1, it is having the value of 34H. Now we are going to write the instructions set bit C, then set bit P1.0. What happens? See here, set bit C. Set bit C means your carry flag will become 1. Understood? Then next, set bit P1.0. You have to set in the port 1, the 0th bit, it should be become 1. Okay, if you see here 34H, initially we are having 0. Now we have to make this bit 1. Then we can use the instruction set B P1.0. So after executing these instructions, your carry flag will be 1 and your data in the port 1, it will become 0011 and 0101. The 0th bit, it will become 1. Understood? So here only the 1 bit we are changing. Okay. Next is the CPL. CPL is nothing but complement. Complement accumulator. Let us consider an example. Accumulator contains 5CH. If we are using CPL A, then the content that is there in the accumulator, this entire bits will be complemented. So complemented means 0 will become 1, 1 will become 0. So the accumulator, the output will be 10, 1000, 11B. The bytes are 1 here. Single bit byte instruction. Next, if we are using CPL bit, so here only 1 bit we can complement here. Let us consider an example. In the port 1 we are having 5DH. Okay. So if we are using the instruction CPL P1.1. So P1.1 initially it is 0. If we are using the CPL, then what it will become? The 0 will become 1 here. So we are easily able to complement the single bit. Understood? Next is the CLR. CLR means clear instruction. It will clear entire content. If we are using clear A, that means clears the accumulator. So whatever the content that is present in the accumulator, all the bits will become 0. Example, if accumulator contains 5CH, then if we are giving the instruction clear A, it will set the accumulator to 00. Okay. If we are using clear bit function, clear bit. So here only the indicated bit will be cleared. For example, in the port 1, we are having the FF. Okay, all ones are there. If we are using CLR P1.2, that means the second bit of this port, it should be cleared. That means here this bit should be cleared. Then the output we will be having is all ones and the second bit is cleared. Only the second bit is cleared. Understood? Next instruction is JB. JB means you have to jump only if the bit is set. So JB is JB bit comma relative address. So this is a 3-byte instruction. If the indicated bit is 1, then it will jump to that particular address. Else it will continue with the next instruction. Understood? See, for example, if the input port 1 is having this content, okay, the accumulator holds 56. Then the instruction sequence JB P1.2 comma label 1. So P1.2. So if you in the port 1 P1.2 means here it is 0. It has to jump only if the bit is 1. So here the bit is not 1. So it will continue with the next instruction. JB ACC.2 label 2. In the accumulator, it will check the second bit. So here the second bit is set to 1. If it is set to 1, then it will jump to the address of the label 2. It will not continue with the next instruction. As is label 2 will be somewhere here or somewhere up. Okay, whether it will be forward or backward. It will jump to the address of the label 2. Understood? And the number of bytes are here 3. Next is JNB. Here it has to jump if the bit is not set. If the indicated bit is 0, branch to the indicated address. Otherwise, proceed with the next instruction. If we consider an example, in the port 1, we are having 11001010B and your accumulator is having 56H. Now the instruction sequence JNB P1.3 comma label 1. P1.3, that means 0, 1, 2, 3. P1.3, here it is 1. If it is 0, then only it has to jump. If it is 1, it has to continue with the next instruction. Since it is 1, it will continue with the next instruction. JNB ACC3, comma label 2. That means the third bit in the accumulator 0, 1, 2, 3. So this is the third bit. So the third bit is 0. So here the bit is 0. Then it has to jump to the address of the label 2. Understood? And here also it is the 3-byte instruction. Next one is JBC. JBC bit comma relative address. This is the syntax. This is also 3-byte instruction. The function of the JBC is jump if bit set. Bit should be 1. After it will, before jumping, what it will do? It will clear the bit also. If it is set, it has to clear and it has to jump. If the indicated bit is 1, jump to the address indicated. Otherwise, it will proceed with the next instruction. Let us consider an example. An accumulator holds 56H. The instruction sequence JBC ACC.3 comma label 1. That is the ACC accumulator, the third bit. This is 0, 1, 2, 3. Here the third bit is 0. If it is 1, then it has to jump. Else it will not jump. It will continue with the next instruction. So it will come to the next instruction. Here ACC.2. ACC.2 0, 1, 2. So this is 1. If it is 1, what it has to do? It has to jump to the address of the label 2 and then this bit should be cleared. Okay. So what will be in the accumulator now? If you check the bit 2, this is cleared to 0. And also it will jump to the address of the label 2. Okay, you got the difference. JB and JBC. In the JB, if the bit is set, it will jump to the particular address. But in case of JBC, if it is 1, it will also jump and then it will also clear the bit. Understood? See, these are the single bit instructions. The single bit, this you can also use for AND, okay, AND or XOR also. You can use the single bit instructions. Now let us solve some MCQs. Which operations are performed by the bit manipulating instructions of the Boolean processor? Complement bit, set bit, clear bit, all of the above. Just now we have seen all. We can for complement we can complement, we can set the bit, we can clear the bit. So the answer is all of the above. Which of the following instructions is used to set bit port directly? So how we can set the bit port directly? Set P1.0, move P1.0 comma bit, set B P1.0, JB P1.0 comma bit. To set the bit port, the bit in the port, you can go for set B P1.0. So C is the answer. The instruction that is used to complement or invert the bit of a bit addressable SFR is. So to complement, whether you are using CLRC, CPLC, CPL bit, ANL bit. So if you choose complement, we'll be using CPL. If you choose CPLC, CPLC means it will complete. It will complement everything. So CPL bit you have to use. If you are using CPL bit, only that particular bit will be inverted. Next, this statement will set the address of the bit to 1. That is set B 01H. Is it correct? If you give 01H, where it has to set? No, this statement is false. This program code will read data from port 0 and write it to port 2, and it will stop looping when bit 3 of port 2 is set. See here in this program, move A comma P0. So whatever the content is there in the P0, it is moved to accumulator. Move P2 comma A. Then again it is moved to P2. JNB P2 comma P2.3 comma start. So here the bit that is in the port 2, the third bit, okay, JNB, if it is 0, then it has to jump to the start. Okay, so here what they are telling, this program code will read the data from port 0 and write it to port 2, and it will stop looping when bit 3 of the port 2 is set. Correct. Here if it is 0, then it will loop. If it is set, then it will continue with the next instruction. So this is true. So today we have discussed the single bit instructions, that is set bit, clear, complement, then JB, JNB and JBC. These instructions you can use to change the single bit in the data or in the register. Understood? I hope you understood today's session. Thank you for listening.